Assalamu alaikum, students of class 9th biology and computer group. In our previous lesson we studied the chemical bonding and the two main types of chemical bond, that is the covalent bond and ionic bond or electrovalent bond, and the differences between ionic and electrovalent bond. The home task was to learn all these topics with examples and equations and figures. I hope you have completed your work and you know that this time is very precious, so please work very hard to get the good A plus grade in your class 9th examination. Okay, today we will start the chapter is chemical bonding, chapter 5, but the topic is polar covalent bond. The topic is polar covalent bond. Now what is polar covalent bond? Polar covalent bond is the bond which is produced between two unlike atoms. Two unlike atoms means the atoms are very different. They are not similar. One atom is more electronegative than other atom. One atom is more electronegative than other atom. What do you mean by electronegativity? I have already explained in my previous lecture. Electronegativity is the relative ability of an atom in a molecule to attract the shared pair of electron towards itself. Actually, it's the ability to attract the electron pair in a molecule towards itself, right? So that this bond is produced in two unlike atoms in such a way one is more electronegative as compared to other. So the electron pair which is produced between the atoms is slightly shifted towards the electronegative atom. It gets slight negative charge and other atom gets a slight positive charge. In this way the polar molecule or a dipole is produced. What is dipole or polar molecule? That is the molecule having the atoms, two ends having positive and negative and that is a charged atom, and the bond is called as a polar covalent bond. Again, what is polar covalent bond? It is a bond which is produced between the two unlike atoms in such a way one atom is more electronegative than the other atom, so that slight negative charge on that atom and slight positive charge on the other atom is produced. Molecule becomes polar or dipole, and this type of bond is known as the polar covalent bond. Now it will be very clear, you can understand easily with the help of example. Consider the formation of HCl, that is hydrogen chloride molecule. You know hydrogen contains only one electron in its K shell. It needs how many electrons to complete its duplet or two? 1. In the case of chlorine, you know atomic number of chlorine is 17. In first shell there are 2 electrons. In second shell there are 7 electrons. In second shell there are 8 electrons. In the outermost shell there are 7 electrons. So it needs 1 electron to complete its octet. So it shares 1 electron with hydrogen and hydrogen shares 1 electron with chlorine. In this way hydrogen completes its duplet and chlorine completes its octet. But because chlorine is more electronegative, so this electron pair is shifted towards the chlorine atom. And in this way, the polar molecule is produced and it is known as the polar covalent. Consider the example of ammonia. What is the formula of ammonia? NH3. It is the combination of nitrogen and hydrogen. That is, nitrogen shares. What is the atomic number of nitrogen? 7. In the outermost shell, it contains 5 electrons. According to the octet rule, it needs 3 electrons to complete its octet. But hydrogen can provide only 1 electron because it can share only one. It has 1 electron. So in this way, it shares 3 electrons with 3 hydrogen atoms. Each hydrogen atom completes its duplet and nitrogen completes its octet by sharing with 3 because it already has 5 electrons outermost shell. So in this way, because it is more electronegative, so this electron pair is denoted by the dash line. This dash line means 1 electron pair. It's shifted towards the nitrogen. It gets a slight negative charge. Again, this hydrogen atoms, they get the slight positive charge is produced on this hydrogen atom and polar molecule is produced. Now you clearly understand what is polar molecule, polar bond, polar molecule covalent. It's a covalent bond formed by the sharing of electron, but atoms are unlike and one atom is more electronegative than the other atom. So slight negative charge on more electronegative atom and slight positive charge on the other atom is produced, and in this way polar molecule is produced and the bond is known as the polar covalent bond. Now, another type of bond is known as the non-polar covalent bond. Non-polar covalent bond. Naturally, from the name it is clear, it's not polar. It is produced between the two like atoms, two similar atoms like hydrogen and hydrogen combine with the share the electron to form the H2 molecule. Chlorine and chlorine share to produce the Cl2 molecule. Oxygen and oxygen share 2 electrons to form the double covalent bond. 2 electron pairs are produced, but actually this is non-polar covalent bond. Now, the shared pair of electron remains in the center. It is not shifted towards, because both have the same electronegativity. The ability to attract the electron is the same, so the electron pair remains in the center. So molecule is called non-polar because it is electrically neutral and also symmetrical. It has the identity is the similar structure. No positive and negative ions are produced or the charge is developed. Dipole molecule is not produced. So very easy. What is non-polar covalent bond? It is the bond which is produced between two atoms, two similar atoms. Electronegativity is the same, so the electron pair produced remains in the center. No charge is produced and molecule is neutral, and the bond is known as a non-polar covalent bond. So two types of covalent bond you have studied: polar covalent bond and non-polar covalent bond. Now, another topic is the role of electronegativity in predicting nature of the bond. Role of electronegativity in predicting the nature of covalent bond, in predicting the nature of bond. Electronegativity, again, you know that is the ability of an atom to attract the shared pair of electron in the molecule. Now, these electronegativity values were calculated by the scientist, his name was Linus Pauling. So, by taking the difference of the electronegativity between the atoms which are combining, we can find out the nature of the bond. What kind of bond will be produced by knowing the value of the difference of electronegativity between the two bonded atoms. Right? First, if electronegativity difference between the bonded atom is 0, the bond will be non-polar, that is neutral. If the electronegativity difference between the two bonded atom is 0, the bond will be non-polar, no charge on the bond. For example, hydrogen and hydrogen. Now, what is the electronegativity of hydrogen? It is already calculated. It is H is equals to electronegativity is equals to 2.1. Another H 2.1. Natural 2.1 minus 2.1 0. So electronegativity difference is 0. The bond will be non-polar. Now, if the electronegativity difference between the bonded atoms which are participating in bond formation is up to 1.7, that is it is more than 0, but it is up to 1.7, not greater than 1.7. So if electronegativity difference between the two bonded atom is more than 0, but up to 1.7 is the bond produced between them will be polar. You have previously seen the example of HCl. HCl is a polar molecule. Now, you know the electronegativity of hydrogen is always calculated. It is 2.1, a fixed value. And the ability of chlorine to attract the electron pair is calculated as 3. Right? So electronegativity of hydrogen is 2, electronegativity of chlorine is 3. Take the difference, 3 minus 2.1, it is 0.9. Again you see 0.9. Again you see it is more than 0. So the bond will be polar, that is a positive and negative. Slight positive and negative charges will be produced on the molecule. It will be dipole molecule and the bond between them will be polar covalent. In the same way, oxygen and hydrogen, they form the polar molecule. So in the water molecule, the oxygen is more electronegative, hydrogen is less electronegative, slight negative charge on oxygen and slight positive charge on hydrogen is produced. So this is polar molecule. Right? In the same way, ammonia polar molecule, right? Because ammonia is more electronegative. Now the third condition is, if the electronegativity difference between the bonded atom is greater than 1.7, the bond will be ionic or electrovalent. What is the third condition? If electronegativity difference between the bonded atom is more than 1.7, the bond will be ionic or electrovalent. Consider the formation of NaCl. Now the electronegativity which is calculated for the sodium is 0.9 and electronegativity calculated for the chlorine is 3. Take the difference. 3 minus 0.9 is equals to 2.1. You can see it is greater than 1.7. So the bond will be ionic. And you know that we in a previous lecture we have studied how the sodium has one electron. It transfers one electron to form the positive ion. Chlorine gets the one electron to form the negative ion. In this way, these positive and negative ions are held together by electrostatic force of attraction to form the this ionic or electrovalent bond. Now, three conditions you remember. Simply on your tips you can learn. If electronegativity difference between the bonded atom is 0, bond will be non-polar, like O2, H2, Cl2. If electronegativity difference between the bonded atom is more than 0 but up to 1.7, the bond will be polar. Molecule will be polar, positive and negative charges. It has the positive, and the bond is known as the polar covalent bond. Third condition is if electronegativity difference between the bonded atom is more than 1.7, like in the case of NaCl, the bond will be ionic or electrovalent, right? So now our now we will study the another type of bond. It is known as a coordinate covalent bond. Its other name is dative covalent bond. The other type of covalent bond is known as the coordinate covalent bond or dative covalent bond. This bond is always formed between the two unlike atoms. Atoms are not same, and it is formed by the one-sided sharing of electron pair. It means both the electrons for the bond formation are provided by one atom. Both the electrons for the bond formation are provided by one atom. The atom which provides the electron pair, for bond formation is called as the donor, or the atom which accepts the electron pair is called the acceptor. It means both the electrons are provided by the one atom, and that is known as the donor, and this electron pair is accepted by the other atom, and it is known as the acceptor. So actually, why atom do so? Why atom do this? Because atoms try to get the stable electronic configuration of the noble gases, right? So as you know that the covalent bond is denoted by single covalent bond by one short line, double covalent bond by two short lines, and triple covalent bond by three short lines. But this coordinate covalent bond is denoted by the head, and head points towards the acceptor atom. And the electron pair of donor is known as the lone pair of electron, because it is not linked with any other atom, it is free. So now you understand what is coordinate covalent bond. It is a special type of covalent bond, also known as the dative covalent bond, which is produced between the two atoms in such a way that both the electrons for the bond formation are provided by the one atom, and that electron pair which is denoted by atom is known as the donor. Other atom which is accept the electron pair is known as the acceptor, and the bond produced between them is shown by the arrow, and the head points towards the acceptor. Now it will be very clear with the help of examples. The first example number 1, formation of ammonium chloride from ammonia and HCl. Formation of ammonium chloride from ammonia and HCl. You know the formula of ammonium chloride, NH4Cl, which is formed by the combination of ammonia and HCl. First, write down the molecular equation: ammonia plus HCl. This hydrogen is added and ammonium chloride. Now I will explain it with the help of dot and cross formula. Now, look at this. Ammonia. We have studied in the Lewis concept also in our previous lectures. The ammonia means nitrogen combines with how many hydrogen? 3. I already told you nitrogen in the outermost shell of nitrogen atom. How many electrons are there? Cross, 1, 2, 3, 1, 2, 3, 4, 5. It needs how many electrons to complete this octet? 3. 5 and 3, 8. But one hydrogen can provide only one electron. So it shares 3 electrons with 3 hydrogen atoms. And in the case of hydrogen, we are showing the electrons of hydrogen by dot. This hydrogen, because for shell, it needs only 1 electron to complete its duplet. So in this way, nitrogen shares these 3 electrons with 3 hydrogen atoms. In this way, the nitrogen completes its octet. And hydrogen, each 3 hydrogen, they complete their duplet. But you can see that there is a pair of electron lone pair. You can see it's not attached with any other atom. It is not attached with any other atom. So it is not the lone pair of electron. So this nitrogen of ammonia can donate the electron to the needy person, to the needy element, right? And it is known as the electron pair donor. And you know that in the previous lecture studied that those substances which provide the electron, they are known as the Lewis base. Electron pair donor is also known as the Lewis base. Now consider HCl. We have already discussed HCl. In the outermost shell of hydrogen there is 1 electron. In the outermost shell of chlorine there are 7 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7. It needs 1 electron to complete its octet. Hydrogen needs 1 electron to complete its duplet. So they share this electron. Now, but in this condition, this chlorine is more electronegative. It has more ability to attract this electron pair. So actually, it attracts the electron pair and it takes away the electron. And this hydrogen is a poor one. It has no electron. It has got the H plus. It means it's completely empty. It needs how many electrons? It needs the 2 electrons to complete this first shell. So this is also known as a proton. You know, H plus ion is also known as a proton. And because it accepts the electron pair from the ammonia, that is nitrogen of ammonia, it is known as electron pair acceptor. In other words, it is known as the Lewis acid. Now what happened? In this reaction, look at this. Now it provides the 2 electrons, but it asks for the sharing also. And both the electrons are provided by the one partner, and then it shares the electron. Partner is not, there is not a mutual sharing. Both the electrons are provided by the one atom. So in this way, this hydrogen combines with this, and this bond is produced known as the coordinate covalent bond. It means both the electrons are provided by the nitrogen, and to the donor is this hydrogen. Because H plus is combining, so whole molecule, how would you read? NH4 plus, NH4 plus. NH4 plus is the formula of ammonia. NH4 plus is the formula of ammonia, and this is the Cl minus. Now this chloride ion is produced and this ammonium ion is produced. Now this positive and negative ion combine to produce the molecule of ammonium chloride, NH4Cl, right? Now the electrons of hydrogen are represented by the dot, and electrons of nitrogen and chlorine are represented by cross. Now you understand how this, by the dot and cross formula, they combine. Now another example is the formation of hydronium ion. Hydronium ion, the formula you know, that H3O plus. Very easy, formed by the combination of water and H plus ion. First we will write down the molecule equation and then dot and cross formula. Water and H plus ion combine to produce the H3O plus. Water and hydrogen combines to the H3O plus. That is known as a proton and this. Now we will write down in the term of dot and cross formula. How would you represent the water? Water contains 1 atom of oxygen and 2 atoms of hydrogen. We are only interested in the outermost shell. How many electrons are present in the outermost shell of oxygen? You should remember the atomic number of oxygen. Atomic number of oxygen is 8. Atomic in the K shell, 2 is completed. How many electrons in the L shell? 6. Now every atom tries to complete 8 electrons. It needs how many electrons to complete the outermost shell? 2, because it has 6 electrons. So naturally it shares these 2 electrons with the electrons of hydrogen. But hydrogen can provide 1 electron only. So in this way it shares with the 2 hydrogen atoms, but hydrogen also needs 1 electron to complete its first shell, that is duplet. In this way hydrogen share 1 electron to complete duplet, and this other hydrogen completes duplet. And what about oxygen? 1, 2, 3, 4, 5, 6 and 2 with, provided by the hydrogen. In this way the sharing takes place and we get the molecule of water molecule. Now you can see it is very rich because it contains a 2 electron pair, lone pair of electron, not combined with any other. Electron pairs are denoted by cross, right? 2 cross, 2 cross, 2 cross, right? So it can donate any electron pair, right? Consider the H plus. It has nothing. It has no electron. It needs 2 electrons to complete the first shell. Now any of these 2 electrons can be provided to this. It provides electron pair and then it asks for sharing. So these electron pairs are provided by this and shared. Simply, this electron pair can be denoted by the dash line. Another electron can be denoted by the dash line. This dash line means electron pair, 1 from oxygen, 1 from hydrogen. But we will write down this electron pair because they are not participating in the bond formation, and these electron pairs are denoted by the cross. In this way, the molecule of hydronium ion is produced. What is the formula of hydronium ion? H3O plus. In this reaction, water is electron pair donor. It is known as the Lewis base. Hydronium ion H plus is the electron pair acceptor. In this way, coordinate covalent bond is produced between oxygen and hydrogen to form the hydronium ion. So now you clearly understand what is the coordinate covalent bond. It is a special type of covalent bond. It is also known as the dative covalent bond, in which both the electrons for the bond formation are provided by the one atom only. That is the one-sided sharing, and the atom which donates the electron pair is known as the donor, and atom which accepts the electron pair is known as the acceptor, and the lone electron pair which is free and donated is also known as the lone pair of electron. Now, okay, now we will briefly go through this. We have already studied the differences between covalent and coordinate bond. Covalent bond is produced between the like and unlike atoms. Like atoms, like H2NCl2, unlike atoms, like HCl. But coordinate covalent bond is always produced between the two unlike atoms, like ammonia and chlorine ammonium chloride. Actually there's a mutual sharing. Both are sharing the electron, but only here the one-sided sharing. Only one atom is providing the two electrons, and this bond will be covalent bond, may be polar, non-polar, neutral, or having positive, negative charge. But this coordinate covalent bond is always coionic. There's a charge is produced in this. Covalent bond is denoted by single short line for single covalent bond, double short line, double covalent bond, for triple covalent bond, that will triple short line, and coordinate covalent bond is denoted by arrow. So now in this lecture we have studied the different types of covalent bond: polar covalent bond, non-polar covalent bond. We studied the coordinate covalent bond, and we studied the differences between covalent bond and coordinate covalent bond. So please learn all these 3 topics with equations and formulae. Okay, and inshallah we will continue the next time. Assalamu alaikum.